Hello, everybody, and welcome to Shark Talk. Today, we have another exciting session to learn how to draw a new shark species. This is one that I've very much been looking forward to. Hi, Julius. How you doing today?
Good. How are you, Ron?
Oh, excellent. So for those of you not familiar with Sharks for Kids, we are a group of volunteers that specialize in creating shark advocates. We go out to schools both in person, but more of late, we've been doing these virtual sessions and they've been working out quite well. And then we record them and you can watch them later at your convenience as well. After today's Shark Talk, I'll also show you the website, show you a little bit around it, how to see where the recordings are, as well as how to see other upcoming events and resources that we have. So Julius, today you picked the crested horn shark, and I have to admit, I hadn't heard of the crested horn shark. I've heard of horn sharks and I've seen them and photographed them, but what's special about the crested horn shark that makes you like it?
It's one of those really neat examples of sort of an extreme among sharks, and we all know there are some pretty fascinating extremes, like longest tail or biggest teeth or whatever. This one is interesting in that it has perhaps the tallest. These are called supraorbital ridges. These little bumps above the eyes, and horn sharks, as you know from your own wonderful photographs, have some really unusual head and body shapes, and very, very tall heads with eyes high on their face. But the crested horn shark specifically has the tallest ridges above its eyes. And the juveniles, of which we're going to draw one today because it's just so special, have even taller ridges compared to the adults.
So it's sort of like my French bulldog when he was a puppy had oversized ears and he sort of grows into his ears. Okay.
Exactly, right? Yeah, it's the whole baby shark thing.
Okay, and where's this shark located at? Because I've never seen it.
They live on the east coast of Australia.
Okay.
In sort of warm, temperate waters, and usually they hang out. They're nocturnal, and they hang out anywhere from about the shore to about maybe 300 feet depth or something like that.
Oh, wow. Okay.
Usually a little bit deeper, I guess. But so they're not too common around where they are, and they overlap with the Port Jackson shark.
Okay.
In fact, they even eat the egg cases of the Port Jackson shark, so it's kind of an interesting thing.
Yeah, excellent. Yeah, maybe as part of the exercise, you can talk more and maybe even draw out some egg casings because they are really cool. I have seen those egg casings around. Let me, hey, do you mind if I show a couple pictures to
yes, please do.
out there? Let me share my screen again. And, I've been really fortunate to swim with some of these sharks, and I shouldn't say swim with them because most of the time they're just sitting around. They're mostly nocturnal, as I understand it, and they're sort of ambush predators, or they'll come out at night. They'll feed on, little crustaceans and mollusks and things, and I think the juveniles may eat softer foods, maybe some anemones and smaller things. But this is one that I found out at Catalina Island, California. It's an island just off the coast of Los Angeles. And this is a horn shark, a slightly different species than the one we'll be drawing today. But these, you can find them quite a bit, but they're very shy. So you have to approach them very cautiously. And you can see those, and what did you call the ridges?
Supraorbital, like above the eye, basically.
Above the eye, okay. And so you can sort of see that, and some other features that will be pointed out that give it its name are these horns. You see those white tips there. And then the mouth is very unique. So these are really cool sharks. I'm glad we're drawing this today. When you do approach them, they actually will start swimming away, and they'll find another nice little perch to just hang out. They really just chill most of the day, and they do most of their hunting at night, and I believe they're solitary. They don't really hang out with other sharks or school with other sharks. I'm sure maybe during mating season that might be different. And then we were down in the Galapagos, and this was probably at about 60 or 70 feet on a night dive. And so we saw this little guy out hunting, and this one, you know, very similar in coloration actually and pattern, but it is a different species, and it's called a Galapagos bullhead shark, which are, you know, horn sharks are part of the bullhead species shark. I understand. Is that correct, Julius?
Yeah, I think they're synonymous.
Okay, so
They're
it's
the
just
same, just another name for them.
okay.
Yeah.
So
Yeah.
in Ecuador, that's what this one's called in Galapagos, because it's found in Galapagos, and cute little guy, but a lot of the same features. And maybe, you know, I learned today already, maybe this is more of an adult because these superorbital, did I say that right? Aren't as big. They're not as pronounced. So
Okay. And
right?
these ones would probably have shorter ones anyway. I think the
Oh, sure.
Galapagos bullhead shark has relatively short crests
Very
in general.
interesting. Very interesting. You know, they're
Beautiful photos. Those are
they
really
blend
nice.
in really well. And you know, this shot I thought was sort of interesting because sharks and rays are related, right? And particularly these species have similar mouths and feed off similar things. So both of them were hunting the seafloor, the sand, looking for little crustaceans, shrimp, or little lobsters that they might be able to eat. And as you see, when we start to draw them, they have a very unique mouth that allows them to crunch up hard things. But just thought I would share these to give everyone a little bit of perspective on what we're going to be drawing today. You know, looking forward, I've got my paper and pencils ready, my different colored pencils. So I'm going to turn things over to you, and we'll get started with today's drawing exercise. How's that sound?
Sounds great to me. Awesome.
I will stop.
Thank you very much, Ron. And by the way,
go ahead.
So I'm off to the side here is because I've got my little helper happening here as well. This
little
dogfish. This is Tycho, and he's helping out here, keeping my blood pressure low and all that, and my hands all properly conditioned by for stuff. So.
Well, maybe some of the people at home have their Tycho next to them, their dogs.
That's right. Yeah, and he's one of our. He's a coworker, right?
Yeah, absolutely. My
offices are different these days, so yeah, he likes his tummy being rubbed, and so it's a big job of ours, and you know he helps out by.
It's a tough responsibility. My little guy Bo is at my feet. He's in his little bed.
Oh, that's sweet.
And also for those of you on the line, as we're going through, feel free to use the question and answer. You should have a little Q&A icon at the bottom of your screen. If you want to ask something to Julius or I, go ahead and do so through that, and then I'll periodically look at that and pose those questions to us, and we'll answer them live, as many of them as we can. So
yeah, that's great. And if you want to interject at any time to just ask a question, yeah, that would work out well for me too.
Sounds good. Sure. We'll do.
Super.
All right.
Okay. Well, we'll get started then. I'm going to share my screen then, and we'll get. Oh, I'm getting a scratchy request from somebody beside me here in the meantime. Here we go. Excellent. Okay, so hopefully you can all see that well. I am going to, actually I'm going to maximize this so that we have it centralized like this. Okay, so there we go. So what we're going to do is you can follow along using whatever drawing tools and stuff you have, you know, whether it be a pencil and paper or, you know, a chisel and rock. If you're, you know, thinking plasticine, that works well too. But I've set this up to be sort of an 8.5 by 11 inch sheet of paper, and this should make it a little bit easier to fit the proportions. And the way we'll do this is maybe a wee bit different from the previous ones, but very similar anyway. You'll just want to use something like a pencil that you can maybe erase out a little bit if necessary, because we're going to create some shapes initially, but these shapes will be very similar to the final shapes as well. So all you're really going to have to do is erase out a few little lines here and there to open up some of the shapes afterwards, and that should make it quicker to get the finished piece done like that. And the nice thing about these kinds of drawings too is that you're basically creating your own coloring sheets. So if you want to then afterwards, based on like the beautiful photos that Ron provided of some of these species and other photos you can find, you can color in these sharks and make them look like they would in life. So what I'm gonna do is start off here with, so we're gonna, you'll want to make it, these first lines maybe a little bit light and sketchy, and then afterwards you can kind of fill them in as necessary. But you know, whatever works for you is fine. And I'm going to start with my layer here, and we're good to go. Okay, so this is going to be one of those neat types of sharks, as Ron was describing, and he's provided some great photographic reference to show how they sit on the bottom a lot, and then they hang out there until they go and hunt for whatever they're eating, and they have a very interesting kind of lifestyle, the horned sharks. They have, their mouth is really strange, as he was saying, and they have, they mostly crush their food a lot more than other sharks do. So their mouth is on the bottom of their head, and so they can kind of sort of vacuum up certain things from the bottom of the ocean floor. And these guys here, the crested horned shark, mostly they eat two species of sea urchin. So what would normally we would consider to be really, really spiny and difficult prey to eat, these guys actually feed off them mostly. They also eat the eggs of Port Jackson sharks, which are a related species. So their teeth can actually become stained by the sort of pinkish purple color of the urchins after a while. So they're kind of neat that way too. Here, we're going to start with making the body of the shark and go from there. So the first shape that we're going to do is kind of almost like a boat. So we're going to go like this, and I'm going to make sort of a sharper end there. And oopsie, I'm just going to get it. Oh, the dogfish is leaving here. So sorry. I have to make room for him to get by. Okay. Yes, I'll continue the shape now. Yeah, we have wildlife interactions happening here. Okay, so then the end of, so it's kind of like a boat shape. It's almost like an oval, but with one end of it is kind of sharp. The other end you can just kind of narrow out like that. Is going to be a little bit thicker. So that is our first kind of a shape, and that'll kind of keep in mind where on the page this is approximately. So it's almost centralized, but that sharper end of it, you want to be closer to one end. So that's the side that you want closest to the edge of your page, because we're going to want to leave some space on the blunt end of it for the tail of the shark. Okay, so that's the first bit. Now we're going to actually add that second half of the shark, sort of the tail end of it. And to do that, we're going to make some lines coming off the side of this bigger shape. So for one, we're going to continue backward from this blunt end and then curl up like this. Oops, I didn't quite like how I did that one a bit. I'll straighten it out a bit, or smooth it out a bit, I guess. I've added a few sort of guide shapes underneath as we're going, just to make sure that we get all the right shapes and such, and it gives you a bit of a preview to see it as well. I set these things up ahead of time so that we get as accurate proportions as we can. It's not the same as quick sketching, but it gives us something that's more predictably accurate. So this is kind of a weird shape. It looks almost like almost like an invertebrate, some kind of an insect or something at this point. Not much like a shark, but we're getting there. Oh, I can't hear you there, Ron.
Oh, I was saying almost like a tadpole.
Yeah, exactly, like a tadpole. There you go. Yeah, that's right. Yeah, and these sharks actually do look a bit more like tadpoles than most sharks do. They have that enlarged head, and much bigger than most sharks do. I mean, remember, like you have those nice sharks behind you in your background there. With the exception of the hammerhead, they have relatively smaller heads compared to their body. But bullhead sharks or horn sharks have a shape that is much more enlarged at the front end, and they're much less hydrodynamic, or the equivalent for aero would be aerodynamic. They don't need to be, because they're not fast swimming sharks. They don't really rush after their prey at high speed. Like these guys hunt sea anemones, or sorry, sea urchins, and those don't really move very fast. So they don't have to move quickly. So this way they can get by with being less hydrodynamically, refined.
So I imagine in Australia, them eating the sea urchins probably keep the balance of sea urchins in the area in check. Another reason, sharks are good for the environment is they're keeping that ecosystem in balance and allowing, the amount of probably kelp to be growing there and other abalone and type. I know off of California, sometimes we get too many sea urchins and that can be detrimental.
Exactly, you're right. And this is one of those wonderful examples in ecology where you have keystone species, as they're called, animals that can change the very nature of the ecosystem itself by their activities, and removing that one species can have a huge effect on the structure of the environment. So as you're saying, Ron, certain sharks that eat sea urchins, and also sea otters are kind of like the poster child of this kind of an effect. They'll eat sea urchins, and because sea urchins are really voracious munchers of kelp, when they overpopulate an area, when there's no control of their numbers by predators such as sharks and sea otters, they munch down the kelp before it has a chance to grow up to these giant, tall kelp individuals. They're not plants, but they look like plants and they function like plants. Those kelp forests don't actually have a chance to grow when there are many sea urchins around. So these sharks, that's right, are actually helping to reduce the chance of overgrazing of these kelp forests. So really interesting point. Thanks for mentioning that. That's really important actually to note. And so now we're going to move along to another part of the shark. This is going to be, so keep in mind, we're looking at, as you can see on the little right up there, it's a juvenile. So it's a young shark. The reason this is important is because as with some animals, these particular sharks have sort of enlarged features. Their fins and their crests are larger when they are small when they're young compared to their body than when they're older. And so the dorsal fin, or the fin on the back of the shark, is also quite tall. So you're going to make this kind of it's not very sharp, it's rounded, and especially like for the crested horn shark, it's rounded or almost rectangular in shape. This is the first dorsal fin. It comes off the body, and it's really tall when it's young. This is extreme in certain species as well, like for the zebra horn shark, which is another species related to this. They're beautiful, by the way. They have this wonderful striped pattern. The young have incredibly tall fins, and they look beautiful and adorable. So their other thing about these guys, it's really funky, and that, as Ron was saying, they've got these specialized spines in front of their dorsal fins that are sometimes referred to as horns, hence their name. Because in these guys, compared to the dogfish sharks, which have more slender and sharper spines in front of their dorsal fins, these are more bluntish. And so what you'll do is you'll go to the front of this dorsal fin and you make this kind of a little hook like this, and then another little hook was like this. And what's happening here is this lower, sort of like a pyramid almost, is an enlarged sort of fleshy part of the fin. And so it's thicker than the rest of the fin. And this part here is the actual spine. And so actually you can make it bulge a wee bit out from the fin, because it does bulge a bit. And so it's actually a really thick spine. And I don't think that it's venomous like in dogfish. I think it's just basically to protect them from predation, and that it makes it more difficult for them to be eaten by something. It's a hard part, kind of like a tooth, like a really big tooth, and it just makes it harder to swallow, right? And would potentially lead to maybe injury for any predator that's trying to swallow them, especially if they're wriggling around a lot. So it's a bit of protection, but not very sharp, not as sharp, still sharp, but not as sharp as for some of the dogfish. But really neat in that they stand out. And there are a whole other order of sharks, there are a whole other group of sharks, like for example, the saw sharks are one group, one order, the dogfish are another, the requiem sharks or ground sharks are another. These guys have their own group and they're unrelated relatively or more distantly related to other types of sharks. So that's the first dorsal fin with the spine. Now there's another dorsal fin, right? Most sharks have two dorsal fins. The cow sharks are an example of one that don't, but these guys do have a second one. This one looks kind of weird because it's kind of a bit twisted at the top. These guys have tall fins, and as they move, they can kind of move around a bit. They're soft, right? So what we're going to do is we're going to make a line that comes up from the back, from the beginning of the tail area. It's up like this, and then there's going to be a little bit of a kind of a hook at the end like this. Comes back and touches it. And then you'll make another line coming from near the top of that down toward the body of the shark like this. What that means is up here, this hooked area, that means that the front edge of this fin is going to the top here, and then the fin is actually kind of twisted around a little bit. So you're seeing the other side of the top of that dorsal fin at the very tip there. And like for the first dorsal fin, we're also going to add a spine to the front of this dorsal fin. This one's a little bit taller than the first one, the spine. So you have that base, that thickened area of the fin first, at the bottom like that. Then from the top of that, you have the actual hard spine that comes out. It's short. It's not very long. But, you know, it's enough for it to provide some protection for the shark. So you get two fin spines. A bit more of a formidable shark to swallow for a predator. And it's important because these guys don't move around much, as Ron was saying. They sit around the bottom a lot, especially during the daytime when they're resting.
What are some of their predators? Other bigger sharks, or?
Actually, that's a good question. It would be larger sharks for one thing. That's often what happens. Sharks often do eat other shark species. And the other thing that this is something that I'm actually not sure about, so I shouldn't speculate too much, but one of the things that you do find that also eats sharks of various species is certain cetaceans, certain whales and dolphins. And orcas are a good example of one type of dolphin that does eat sharks. And so that's something that maybe, you know, they would have to watch out for. But seals also eat sharks. There's this interesting photos I saw recently, and you might have encountered them as well, of a seal eating the remains of, or it was a sea lion eating the remains of a big eye thresher shark, which is pretty weird to see, but yeah, they do actually as well. So there are a lot of marine predators that could take down a shark, and especially a small one. These ones grow to about anywhere from 3 to 5 feet in length. 5 feet is really long for this one, so they're small sharks. So there we go. That's our two dorsal fins with their spines. So that's one of the key features of this group of sharks. Now they also have these paired fins, right, underneath. And these will help them to not just swim, but to prop them up on the bottom. They're really neat. These are big fins. So we'll start with the right one, or the shark's right side pectoral fin, which is the equivalent of our arms, basically. So you go to the middle of that sort of boat shape, and then there's this bit of a bump near the base like that, which is kind of like an enlarged, almost like a shoulder area. And then the fin comes down and backward, and it's quite rounded for a shark and very large compared to the body. Now remember also, we're looking at the shark from a bit of a slightly forward angle, so it looks a little bit larger compared to the body than it would in life maybe, but it'll become more clear as we add all of the rest of the details on the shark. But we wanted to make this sort of interesting so the shark is a little bit facing toward us, just especially to highlight those crests that we're going to put on it.
Yeah, that's what I really like about your drawings, is they're three-dimensional. They're not just a flat. They look like the sharks are coming at you. Or
yeah, and I think that's more fun when we can kind of show them in ways that we would more likely see them. And you know, you can see sharks from the side. And the first time I ever saw a shark, it was from the side in the wild, because a lot of the time they kind of like to swim around you and check you out. This was a black-tip reef shark. But a lot of the time with these guys, as you've been diving with them, you do see them from many different angles when they're on the bottom on the seafloor and not swimming. And so, yeah, if we're coming up to them maybe from the front, we'll see them like this. And I think it's fun because it gives us, it shows us that we can all draw things in ways that are more interesting than just, a side view, and gives us perhaps a bit more confidence in our drawing. I think that's important. So as I said, these are paired fins. So there's another fin on the other side of the shark that is the left pectoral fin. And that one looks like this. It comes down as a bit of like a hooked little shape here. And the reason, and then we'll continue backward from it like this, the reason it's a little bit hooked at the front is, again, we're seeing this fin from sort of partly sideways and a little bit from the front. And so these two fins are used to prop the shark up, and the tips of them are kind of curved outward. So the shark is sitting on them almost like you'd be sitting on your elbows or like on your forearms, propping yourself up off the bottom off the floor if you were laying on your stomach. And so these are large fins, and this shark can really use them quite well to lift its head above and maybe get a better view of its surroundings, especially because its eyes are also very high, as we'll see in a second, and can see if there's prey around it, for example. Okay, now, so that's one set of the paired fins. There's another set of paired fins called the pelvic fins, and those ones happen further back from the pectorals. We're only going to see one of these pelvic fins, though, because that huge pectoral fin is kind of blocking the way of the other one. Okay? So the pelvic fin, which is kind of the equivalent of our legs, or the hind legs of dogs, for example, this one is the shark's right pelvic fin, and it'll come off that initial boat shape body like this. So and we're looking at this a little bit edge on, so you'll see it looks a little bit sharper at the bottom like that, and it comes up and meets the base of the tail. So you're looking at this fin a little bit edge on, especially toward the bottom, because the shark's body is a little bit twisted away from us. And so that bottom edge is actually kind of facing us. So if I were to put in a few dotted lines to show kind of the edge of the fin, the front edge, kind of like that blade-like front edge, it'd be a little bit like that. You don't have to put those in there. The other fin, the other pair would be on the other side of the shark. So we can't see that. As you can see, this giant fin here is kind of blocking our way. So we're not going to worry about trying to show the shark's left pelvic fin because it's hidden from view. And that's okay. That's normal. That's how you often see things in the wild, right? This shark has one other... Oh, were you going to say something, Ron? Oh, sorry. Okay. I wasn't quite sure.
Sorry, I was muted. I was agreeing with you. Sometimes, I know when I take a picture and it's to draw it is you're drawing the reality of how it is and the curves and everything. But when you see the finished product, then it all flows and it makes sense. We had one of our guests had to drop off, but they're going to watch the recording later. But when they dropped off, they just wanted to tell you that they did buy a set of stamps, the T-Rex stamps.
Oh, nice.
That you have, and I'm assuming it's the T-Rex ones. It could be maybe the shark ones or others, but they said they're really awesome, by the way.
Oh, cool. I'm glad to hear that. Oh, that's really great. And yeah, right. If it happened to be the shark ones, then yay,
yeah,
even more for sharks. So that's cool. Well, thank you. That's nice. It's always nice to see that the things that we artists produce are enjoyed by people.
Yeah,
it's rewarding to see that. So that's great. Cool. Well, thanks for passing that along too. I appreciate that. So then now we have one other fin to do before we do the tail of the shark. And that's the anal fin, which is that small unpaired fin. So it's a single center line fin, kind of like the dorsal fins, but on the bottom side of the shark. So it happens actually after the second dorsal fin in this group of sharks. The anal fin is a small fin. It's the smallest of the fins of the shark of this type. And this is usually the case for most sharks. And it comes off the sort of the bottom tail-like lobe like this. It's a little bit rounded. It's mostly triangular. And it doesn't serve much of a purpose in this species because they don't really swim all that much. But it's still there, and it still does help them to basically stabilize their movement as they swim, and probably to provide a bit of propulsion as well, because they're very near the tail Okay, so those are all the main fins. There's one more fin of the shark, which often is not even really thought of as a fin, but it is the caudal fin or the tail fin. And so that one is technically a fin as well. And this is neat about these guys. They have a really large and unusual and very distinctively shaped tail fin for sharks. Like other sharks, it has a condition called a heterocircle, which means that the two lobes are of different lengths and the upper lobe is longer. But in addition to that, it has a very large, what's called a subterminal tip. There's a sort of a flap on the upper lobe that hangs off, that's before the tip, and it's quite large in this species. So you'll go to the end of that line you drew on top, on the back of the tail, you'll go down from it, and you'll note that tip that we drew is actually the base, the end of the shark's sort of spinal column. Now here's the lower lobe. You saw that notch that I drew there? That's kind of the notch that helps define that subterminal tip. That sort of, the subterminal tip is this one here. Subterminal means sort of before or under the end. It's not quite at the end. It's before the end. And so this is the sort of the terminal tip here. But this one here, the subterminal tip, is actually quite large in this species, and much more so than in most shark species. It's something that you see in often in slower swimming sharks. They have a more well-developed sort of kind of a flap on top there. They don't need their fins very much for fast swimming, so you get a lot of difference in length of the two lobes. But the other thing that is interesting about these is you see these kinds of relatively short, sort of squat, but large surface area tail fins on sharks that kind of don't swim much but need their fins for bursts of speed, sudden bursts of speed. Like, for example, the cookie cutter shark, which will have to suddenly catch up with a fast swimming large animal that it takes a bite out of. It's a parasite, right? So these guys, perhaps what they're using this is for escape or to grab their prey suddenly. They are, as Aron was saying, ambush predators. So they'll wait around until something swims near them a lot of the time. And okay, these guys don't hunt fast swimming prey for most of their food because sea urchins don't move fast, but they do hunt other things as well. And small invertebrates, small fish are taken as well. And if they can, they need to, have a burst of speed to catch them. So that could be useful.
Yeah, so sometimes when you approach them too fast and they're just sitting on the bottom, you actually get to appreciate that burst of speed. It's somewhat startling when all of a sudden they're facing you and they can, in a split second, just turn and swim away. It's quite fast and makes you pause a little bit.
And that's an interesting point, actually, because a lot of animals that have to escape predators use this kind of burst of speed to escape, not just because it gives them a head start, but because it startles the predator. And that's actually useful behaviorally. Startling a predator with an unexpected movement can throw them off enough that maybe they pause long enough that they aren't able to catch up with the prey. That's something that we study in ecology and in behavioral ecology especially, about one of the strategies that many organisms do use to escape from predators. So that makes sense a lot as well, that suddenly changing direction and then bursting off, which is really cool. The other thing I was going to say about this guy, it'll come to me later. Anyway, so we've got most of the body of the shark drawn now, and it's sitting on the bottom, kind of resting on its haunches, so to speak, on its big pectoral fins. Now we can add these parts of the shark that I think make it absolutely adorable, and especially because it's a juvenile, these features and this kind of shark are enhanced. Not all sharks have this condition called allometric growth. What that means is that the babies look different in their proportions than the adults. So allo means different, and metric referring to the lengths or the measurements of various parts. So differences in the measurements with growth. So these sharks have very tall fins and tall crests when they're young, and that's what makes them, I think, so cute in this case. Not all sharks have this. So lemon sharks almost look like carbon copies of their parents, but just miniature. These guys look a little bit different. So here we go. Let's draw those crests. So it has two crests. One is on the left side and one on the right side, one above each eye. The left crest looks like this. You're going to start from the nose of the shark. You're going to go up like this. And then there's a wee bit of almost like a notch. And then there's a slight bit of a second bump, and it comes up and then turns back downward. That. Okay. That looks crazy for a shark. You don't see many sharks that have headgear that is this prominent. This is probably the most impressive shark when it comes to its headgear, aside from, I guess, the hammerheads. And of those, the winner, I think, is the winghead shark, which is actually one of the sharks that we drew in this series. It was the second one that we drew after the tiger shark. The winghead shark is amazing, and you can see behind Ron, the great hammerhead shark is also a spectacular example. There you go, he's pointing at it. Those guys have amazing headgear. But if we don't consider the hammerhead sharks as a whole, these horn sharks have the most impressive headgear, I think. There are other really cool ones too, like the dagger nose shark, and I was really waffling about doing that one, and one of these ones would be nice to do in the future as well. It's also critically endangered, so very important to be aware of. They have these long, narrow, weird snouts. But these guys have these amazing crests. So that's the left side crest of the shark. Now we're going to have to add the right one. So that's above the left eye. The right one, you'll see this is kind of weird. You're going to start here. And the reason I didn't bring the back of the crest all the way down to the body is because we're going to start the right crest, and it goes just below that. And there's this other little notch here, back, and it curves around and comes back in toward the body like that. Look at that. It's like it has two horns, like it has two extra fins on its head. And part of the reason why they're so big is because it is a juvenile. The young, of course, because they have this allometric growth patterns, they have very enlarged crests on their head. And it's okay for them. It's not something that would interfere with their birth, because for like the spiny dogfish, which is live birth, born alive, it actually has little protective covers on the spines in front of its dorsal fins, which help to protect the mother during the birth, because those guys have venomous spines, right? They emit poison, basically. These guys hatch from eggs, and so there's no injury to the parent when they hatch. So they can have, or to themselves, they go head first out of the egg, and so these spines are not, or these crests are not really that big a deal for them. But look at how tall they are compared to the body. It's a really neat thing. So what we're going to do now actually is, if you want, you can kind of erase out part of this line here of the body that we drew, because then we don't really need that to be showing. So I'm going to just show you what part of, because you're using a pencil. If you are, then this will help. This body that we drew here, you can kind of erase out part of this like this, because this headgear, this special crests above the shark's head are actually not flexy fins, but they're hard, basically. They're part of the head, and they're just lobes of the head that come off like this. The other thing we can do actually while we're erasing, we have our pencil erasers out, is you can sort of erase out part of that body that comes, that kind of cuts into this pectoral fin on our side. Not the other pectoral fin, because the one on the far side is behind the body. But this part of the body can be pulled off, because it's not going to be seen, because it's hidden behind the pectoral fin that's on our side, like that. You can also actually erase out a little bit of the front part of this body from the front part of the pelvic fin, but only the front part, because like for the pectoral fin, you can see there's that flap that's behind at the back end of the fin that separates from the body, basically, like that. So there you go. And if you want to, you can also kind of partially erase out some of the body from underneath that bigger sort of front pyramid-shaped part of the dorsal fins, where I was saying there's that enlarged part of the fin just below that spine or horn. And that you can do that kind of for both of the dorsal fins, because that sort of just goes to show that it's kind of an enlarged part of the fin, that it's thicker there and it's more flush with the body compared to the rest of the dorsal fin after it. Okay, so there you go. Okay, so now we don't have too much left of the shark, but we need eyes, right? And these guys have eyes, as we were talking about, just below these supraorbital ridges. They're called these two crests on the head. And it's a baby shark, and its eyes are a little bit larger in proportion to its body than the adults. And these guys are sort of oval-shaped eyes. They happen underneath those crests. And so you go like this. You make a little oval like that. Right there. You can actually even give, they have these slight bit, and they look almost like, whoops, they look almost like eyelids, a little bit of a kind of like a line above and below it, sort of like this too. Interestingly, these sharks, compared to others, they don't have what's called a nictitating membrane. The nictitating membrane is a third eyelid that is present in many animals. So our eyelids are composed of an upper and lower lid, and they can close to protect our eyes, but they're totally opaque. They're not see-through. If you look at your eye close up, you'll see that, and if you pull away your lower eyelid or the front part of your eyelid, you'll see there's a little reddish little bit in the front corner of your eye. That's what's left of what used to be a nictitating membrane in our far ancestors. It was a third eyelid that could go over the eye from the middle to the side and close off the eye underneath our eyelids. And in many species, that's actually transparent. So an animal can maintain full vision of its environment without having to close its eyelids and still be able to wash its eyes with tears to keep them moist. In the water, that's not an issue, but it helps to brush the eyes off from either, things that settle on them or parasites that try to attach, or to protect the eyes when, say, an animal is attacking prey that might have spiny bits, for example. Now, these guys don't have a nictitating membrane. They do have, and that's weird for a shark in many ways, but it's one of the things that horned sharks don't have. One of the neat things about their eyes, though, is their pupil. So the black part of our eyes, the pupil is the hole in the iris, the colored part of our eye. And these guys have a neat shaped one. It's kind of an S shape almost. So in the middle of the eye, you're going to draw this. It's mostly long. It's sort of diagonal like this, but it has a little bit of a curve on each end of it. It makes it almost S-shaped. And so during the daytime, these eyes have a pupil that is mostly closed. It's a kind of slit, almost like a cat's eyes. But at night, these can open up wider. And so you'll often find this in sort of nocturnal animals, as they have eyes that can close their pupil quite well, very, very much so. And so that mostly what you see is the colored part. And these guys have more sort of a golden colored eye, or the iris of the eye. And the pupil is that black sort of slit during the daytime. So here we go. That's kind of most of the shark's shape. Actually, what else you can do is, if you wanted to, this will be more accurate. That body of the shark, we can erase out one more little bit. At the very front end, where that left crest begins, you can erase out part of the body line that we drew initially, that boat shape, up to just about to the beginning of that right crest. Because again, these crests come off the sort of the nose of the shark, or the snout, but they're mostly flush with it, so you can leave a little bit of it there, but it just goes to show how much they come off like this, and it's a little bit more accurate like that. That bit in the front here is just very curved on the nose, so we won't have to worry about that. And we're also seeing the shark a little bit from the front, so that's why these two crests are offset from each other. One of them is appearing in front of the other, because we're seeing it not quite nose on, not quite fully sideways, but sort of in between, in a position sort of known as oblique. An oblique angle of the shark. Okay, So there's a couple of things more we need on this shark. Is we need a way for it to eat and to sniff, right? Because it needs to be able to detect its prey and to ingest its prey. And so for one thing, we're going to add these wonderfully developed sort of flaps around the nostrils of the shark, these nasal flaps. Horn sharks have extremely well-developed nasal flaps. In fact, there are these little flaps of tissue that completely separate the part of the nostril where water comes in and the part where it leaves. And so water can go in one direction past the parts of the nose that detect smells, right? So they can be very effective at picking up scents underwater. And what we're seeing from this sort of side view is part of those flaps, and they're really well developed, and they look absolutely adorable when you look at them face on. So, and this is partly face on and partly from the side. So you're going to draw these little bumps, this on the front, one there, and one here, and it kind of overlaps like that. Okay. So now we're going to have to modify a little bit of that body shape and erase out a little bit of that initial body shape that we drew. This part on our side, that lower bump you drew, I'm going to erase out part of that body line that you overlapped with, that. But we're going to add one more detail to these little bumps, which are those special nasal flaps. On the one that's on the other side, or the one that's more forward, you're going to draw this wee bit of a kind of a hook. It looks like this. And on the one on our side, there's going to be kind of a little hook like this. And those kind of refer to the way that the shark's complex shaped nasal flaps work. Now, this shark is really interesting because if you were to look at it sort of face on, we would have something that looks a little bit like, I'm going to try to sketch it here. You don't have to do this yourself if you don't want, but I'm just going to give you a little view from below. If you were to look at this shark, this is its snout area. So looking at it from below, remember. Okay, so there's the snout. Now, these nasal flaps we drew are kind of rounded in the front like this. So you drew two of them, and they very complex in shape. They have these bits that come off like that, and then there's the actual part of the nostril is here, that, and then there are other parts that go in front or more in toward the middle, another flap like that, and then in addition to that, the mouth it happens between the nostrils like this. It's quite small, the part that opens, but there are these sort of thickened, sort of lip-like bits. So there's the mouth actually goes further back like this, both sides, and then there's these kind of sort of like lip-like flaps that come off like that on the top jaw, and on the lower jaw it continues in as well toward the mouth like that. Okay, and then at the front of the mouth you have, and this is wonderful about these sharks, they have two different kinds of teeth. I love them for this as well. They're extremely well evolved for their lifestyle. They eat urchins mostly, so they need to be able to grab them, but they also need to crush them. And so most sharks can only grab and cut their prey. They have these larger, sharp, knife-like teeth. These guys are neat because if you look at an individual tooth in the very front of the jaws, so those little tiny little triangles that I drew in the front here of the mouth, they have sort of five lobes or five cusps. They look a little bit like this. You looked at them from the front. Okay, so that's the gum line. They have sort of five little points. And well, those side ones are actually quite a bit smaller. Each of these species of horn shark have slightly different shaped teeth, and these guys look like this, and they're approximately 1/2 centimeter, or maybe about a 1/5 of an inch across. So they're not very big, but decent size.
That's the front teeth that they grab things with, and they have several rows of those ones. But they're very small still, and they're only at the front of the jaw. If the shark were to open its mouth really wide, and actually these guys can open their mouth quite wide when they want to, because they need to be able to fit that sea urchin in. These things have these long spines, remember. I don't know how they managed to actually crush those, but the back teeth are totally different in shape. If you were to look at a back tooth from the side, it looks like this. Flat and rounded. And those ones they can crush with. They're in the upper and lower jaws. And if you ever have a chance to look at the skeleton or the jaws of this shark, if you Google them, for example, you'll see they're spectacularly shaped jaws. They go way out wide in the back, and they have a bunch of rows of these flat crushing teeth, and they can crush the sea urchins with them. So it's beautiful to be able to see sharks that have this spectacular specialization in their teeth. And so what we can do now is actually add what's visible of the mouth of the shark from this angle, which isn't very much, but I've drawn you a picture of it from below, so you'll see what it looks like anyway. But what you do is you go underneath that bit of that sort of nasal flaps, and you draw a little bit that comes like this around. And then again, we'll erase out a little bit of that body line that we drew initially, because it overlaps, the mouth overlaps like that. And then there's one more little line that we add to the mouth coming in from the bottom of this lobe we drew, and inward like that. And this represents, you know how I drew down here those flaps, those almost like lip-like lobes on the mouth? Well, that's what we're looking at, but from the side. So you're seeing those those flaps at the back of the mouth are basically these are areas that allow the shark's mouth to expand out really wide and open wide for these large sea urchins. And so you're seeing them folded together. So they're again specialized adaptations for the particular food that they eat and how they feed.
So Julius, I had a really interesting comment in the question about, and I believe referring to the eye slit. It looks like if you've ever seen on a cello or a violin, the F hole,
Oh, yes. Yeah.
I think that's what they're referring to. It's a really good analogy of what
that is actually a very good one. Absolutely, it looks exactly like that. Yeah.
Slight, it's not an S. It's a slight.
Right. It's a more long center part with a little bit of a curvature or curl at each end. Or for mathematicians or math buffs out there, the integral sign.
Integral sign.
It looks like that as well. Exactly. Yeah. No, thanks for that. That's a good point. Yes. This helps to bring it home to people with musical backgrounds.
Yeah, we have some very talented people on today.
Yeah. Right on. Cool. It's nice when you get comments like that from people who bring a whole other sort of perspective into it. That's cool. That's awesome. Okay, so there you go. So that's the eyes. They have very specialized eyes, and close to the same size as when they're adults, but a little bit bigger. But they're really, really cute. The other thing this shark needs is a way to breathe, right? And they breathe by way of gills. And so they have 5 gills, like most sharks do. And these gills happen just above and in front of the pectoral fins. Now, this shark is propped up on its pectoral fins. So this little bit here, that little wide area, that is actually kind of like a shoulder area. So the fin mostly starts around here. So these fins or these gills they look like they're right above the pectoral fin. Part of that is also because we're seeing the shark a little bit from the front. So here we're going to draw one line coming down here. That's the front one. It's the longest one. And as we go back, the gill slits get shorter and shorter. So the second one here, third one, you can see it's shorter now. The fourth one is even shorter. And then the fifth one is the shortest of them all, like that. And remember that these are openings on the side of the shark that connect it with what's called the pharyngeal cavity, the mouth area, and just behind the mouth. That's all one open space. And inside of these gill slits are the gill filaments, which are where the oxygen gets taken out of the water for the shark to be able to use in its body. And then the water passes out through the gill slits after it's removed some of the oxygen from the water. Okay, so that's the gill slits of the shark. And that pretty much does most of the shape of the shark. There's one other thing about the shark is that its color patterns are distinctive. Ron was showing you beautiful photos of two species there, both with interestingly similar color patterns, the Galapagos horn shark and it's the California horn shark, I think was the other one. Or what was the name of that one? I think that's...
the Galapagos bullhead shark, and the California was just called the horn shark.
Right. Good point. Okay, that's it. Yeah. And so those two species have these beautiful black spots and some slight banding, I think, as well. But this one here doesn't have the spots, so it's a lot less distinctive or a lot less fine scale coloration, but it has larger blotches. Well, one other thing is actually one more place where we can erase out part of the body line is the very back end of that boat shape we made initially, just so that we open up the body like this. You can leave a little bit of it there just to show that there's maybe a bit of a crease, but not much. And then now we're going to add the colors. Well, we're going to add the edges of those patches of color. And you can color these in afterwards if you like, but I'm just going to show you where the edges are right now. And to do that, we're going to remember that these sharks have one set of patches so the actual crests are mostly dark. So that's sort of you know what I'm going to do? I'm going to make this in a different color just so that it's clearer that what part is color, what delineates color, and what delineates or what refers to actual body shape. I'm going to make these in sort of a reddish color, just to make it clearer. So here we go. Above the eyes, you have this sort of dark area, and I'm just going to put a bit of hatching there just to show you. And then on this side here, there's a bit of a dark. Okay, and then underneath the eye, that blotch sort of continues. That's sort of one blotch, and that's also darker. Overall, they have sort of a tan-colored background, and then these are darkish brown to black, depending on how old they are, and between individuals, there's a bit of variation. These patches of color. There's one that kind of comes in through the gill slits like this. And it's sort of darker around the gills. Yeah. So underneath and around the gill slits, it's kind of darker. And then there is a patch that happens behind the head on top, like that. And then there is also a bit of a saddle that happens back here behind. How does that work? There's kind of a little bit of a dark area behind the fin like this. And then there is a saddle that happens like this down below the dorsal fin, the first dorsal fin. And there's a bit of something comes up from underneath here. Main part of the body. There's actually I think there are about 5 of these saddles of dark color on the shark. So there's 1, 2, 3, 4. Oh yes, and there's one more sort of toward the tail here. Sort of like that. They're a little lighter on the bottom too. It's called counter shading. It's a condition that helps animals to sort of erase themselves against the background because it cancels out some of their shadow to have a lighter color on the underside of the animal. The other thing that happens is that there's a bit of a darker patch on the pectoral fins. It's not sharp edged like this so much, so those edges are not quite as sharp, but they're kind of a rough idea of where the edges are close to. And then there are a few like edges of the fins that are a little lighter in color. So there's like one lighter front edge of the dorsal fins, and then there's like a little front edge of the pectoral fins that's also kind of whitish and things like that. But that gives us most of it. The last thing that I want to point out about this shark, the really neat thing is its egg case. And as Ron was saying, they have these beautiful shaped egg cases. And so, you know, you if you want to, you can. You don't have to draw this, but I'm going to draw an egg case here because they are so cool looking. So to think of their evolution, think of the egg case of a cat shark as an example. And cat sharks have these egg cases that look like this. Just put it in like that. They have sort of a central pouch bit where the embryo is inside. I'll just draw a little embryo curl up inside there. And there's a little baby cat shark in there. So we're talking about a cat shark. This is a different group of sharks, right? And so they have a little baby that's curled up inside there like that. That's sort of the central pouch of the egg case. And then they have these little tendrils that come off like that. And they curl and twist around. And it's meant so that it can get tangled in seaweed and various other kinds, in rocks and such, to hold it in place so that it can't be taken away easily by predator, for example, and to maintain a position stably in the water column so it doesn't get blown away by currents. Now imagine taking that egg case, grabbing the two ends of it. Let's say you're the process of evolution over time, and you take those two ends and you twist them in opposite directions and just keep twisting. What ends up happening? Well, what you get is a horn shark's egg case. You get a spiral-shaped egg case. So you get two edges that basically you get a double helix. So this is what it looks like when you find one of these egg cases of this species, at least. It ends up looking like there's about 6 or 7 turns of an edge. This. And it gets wider and wider. It's auger shaped. So you know that tool that you use to drill into ice, if you're ice fishing, for example? It's called an auger. Well, there's a very specific function that these have evolved to be like this. And so I'll just finish it off. So this back end here, that's where the baby shark actually emerges from. It's that wide end. And when it emerges, the sort of the two halves split open and the shark swims out, pushing its way out. But at this end, the sharp end, some species of horn sharks don't have, most species actually have nothing there. And sharks, some species will actually secure them in between rocks or in crevices or between other hard objects. And these things can be twisted in, and like a screw, they become wedged in place and can't be pulled out easily by predators. So it's a wonderful strategy to protect their young before they're hatched from predators. Because you know how many species of animals like to feed on eggs. These guys actually like to feed on the eggs of projection sharks. But in addition to that, this species has something else. So those two tendrils on each side of the cat shark egg case that I drew, imagine that one half of them are gone. That's the half that's at the end where the shark emerges from, as I mentioned. But there are still two tendrils left on this species egg case on this end. And so they come out like this, and then they tangle around like crazy. They can be up to 2 meters or 6 feet long, these tendrils. The egg case itself is only about, I think it's about like 4 inches long or so. But so imagine this 2 meters of tendrils can get really well tangled up in seaweed and various kind or rocks or whatever it encounters. And so not only can this egg case twist into between hard surfaces, but if those hard surfaces aren't around, because this shark likes to hang out on seaweed or on rocky bottoms or various other kinds of, say, soft bottoms, it can still secure its egg case pretty effectively if it can tangle into soft things like algae. So it's a beautiful example of evolution helping to secure the eggs of this species.
Oh, that's really interesting how that twisted, and I have seen those out in the ocean. And actually this last week on Martha's Vineyard, we were walking the beach and we found a more of the traditional shaped egg casing. You know, they call them mermaids' purses, or
Yeah,
you know,
right.
as a nickname. But yeah, it's pretty special to see those, and how the little baby shark is in there, or baby ray. It could even
Rays,
be,
right? Yeah.
rays
Skates have these a lot.
similar.
Right. That's amazing. I'd love to be able to find one. We did see some of them actually. So I was a participant on as a researcher on 3 of the deep ocean hydrothermal vent cruises off the west coast of North America and the Wanda Fuca Ridge and Explorer Ridges. So we got to see with the remote operated submersible various kinds of deep ocean life about a mile below the surface. And one of the things that we saw quite a lot, even away from the hydrothermal vents, which are those areas where hot water is spewing up from under the surface through these volcanic sort of the active areas. We saw a lot of these bright yellow, what Ron said were called mermaids' purses. And mermaids' purses, yes, are the egg cases of these particular kinds of cartilaginous or these soft skeleton organisms like sharks and rays. And these ones in particular were of certain kinds of deep ocean rays, or skates actually. And they were bright yellow colored. And it's just beautiful to see that, just sitting on the bottom, these bright yellow mermaids' purses. And of course they would be invisible without bright lights. So the yellow color, I'm not sure actually what those ones particularly function, but remember that many kinds of sharks and probably rays and maybe even their eggs might be to some extent fluorescent. So you shine certain light on them and they might glow a different color as the light loses energy and is re-emitted at a different wavelength. Anyway, so that's yeah, that must be neat to find them on the seashore as well. I've never seen one up close and personal. That must be pretty awesome.
Yeah, my friend had never seen one either, so I gave it to her to, you know, have as a momentum.
Very cool. Very neat. Wow. Cool. So there we go. And that is our shark. That's our
cool.
baby crested horn shark. An unusual species, an uncommon species off
that's
Australia.
really cool. This one was a lot of fun. Want to thank you for taking us through this. This one I didn't see how it was going to come together, but boy, and I knew what the shark was going to look like, but I couldn't see it. But it came together really cool. So, and I think everyone also learned some interesting facts about the crested horn shark, and it's a species that maybe doesn't get the attention of the great whites or the hammerheads or the whale sharks, but it's a really cool species, and as we talked about it's really important to the ecosystem to keep everything in balance, and it's part of that food chain. So with that here, I'll show you mine. It's hard to come across.
Yeah. Oh, cool. Yeah, yeah. I can see bits of it in and out. Yeah.
It's coming in.
Very nice work.
But
that's excellent.
All I had was a carpentry pencil. I couldn't find my...
Oh, nice. See?
Anything
works.
So basically chiseling stone.
Right on. Yeah, exactly. Kind of like, that's cool.
Yeah, but I wanted to thank you once again. You've done so many of those for so many of these sessions for Sharks for Kids, and I know they're one of the more popular ones that people download because they're great. You can do them anytime, and at the end you're rewarded with this really cool shark image, and you can practice and color it in and shade it and do all that stuff later. But with that, I'm going to go ahead and stop today's shark talk, and just wanted to see, Julius, if you had any closing remarks for the kids out there.
Well, I think that the main thing is, I mean, I love what you guys are doing, advocating for sharks and showing how important they are ecologically, how much we need them, how they help to keep ecosystems in balance so that they increase the diversity of species, the number of species we see, and the proportions of those. It's very important to the health of ecosystems, and we rely on that because the fish that we eat from the ocean, many of them grow up in environments like coral reefs where sharks are a very important component of that ecosystem. So we need sharks to help maintain ecosystems that help feed us as well. So again, just underscoring how important sharks are. Another thing is that this Saturday is International Coastal Cleanup. So if you have a chance, you could also help sharks by going along, if you have any beaches, to go and pick up plastic especially, that might have been discarded by people who are maybe, you know, less careful, so that they don't entangle or get eaten by marine animals like sharks and interfere with their digestion, or to, you know, in some cases, to ensnare them and prevent their growth, or cut parts of them off, you know, and injure them. And if you pick up the plastic, which can last for hundreds or thousands of years if you don't, this will help. You will be actually physically helping to prevent injury to these important animals.
That's a very good tip, and I didn't realize that was this weekend. So
Saturday. I'll be doing a 10-kilometer sort of coastal cleanup thing as part of a particular kind of a project that's being done around here in Vancouver, good. And hopefully others will join in with the fun and see how much we can collect.
All right. Well, hopefully the Sharks for Kids crew will get out there and do some of the cleanup as well. So excellent. With that, I'm going to end today's Shark Talk, and thank you everyone for joining us. And I know we all learned a lot, and thank you, Julius, and we will see you next time. Thank you.
Thanks very much for having me.
Yep.
Take care.